Have you ever gazed up at the night sky and wondered what happens to old satellites and rocket parts? In the vast expanse of space that lies just beyond our atmosphere, there exists a world far busier than you might imagine. It's not just stars, planets, and cosmic dust up there. Our human curiosity and thirst for exploration have filled the sky with thousands of artificial objects. These are satellites that beam down your favorite TV shows and GPS directions, pieces of rockets that have launched astronauts and scientific instruments into the cosmos, and countless other fragments from our ventures into the final frontier. But have you ever stopped to ponder what happens to these objects once they've served their purpose? Once the satellites go dark, the rocket stages burn out, and the mission is completed? Well, they don't just disappear. They linger, they drift, they clutter. They become what is known as space junk. So, what happens to these objects when they've served their purpose? They become space junk. Space junk didn't always exist. It's a byproduct of our exploration and commercialization of space. So where did it all begin? Picture this. The year is 1957 and the Soviet Union launches the first man-made satellite Sputnik into space. This marks the beginning of our journey into the cosmos, but also the genesis of space junk. As we ventured further, more and more missions followed Sputnik's trailblazing launch. Each mission, whether it was to observe our planet, explore distant celestial bodies, or to establish communication networks, added to the growing collection of space junk. Think about it. Each satellite launched, each rocket sent soaring into the cosmos, they all left something behind. Spent rocket stages, defunct satellites, and even tiny fragments from collisions or explosions. They all stayed up there, orbiting our planet at breakneck speeds. But why didn't these objects return to Earth, you might ask? Well, here's the thing. In the vacuum of space, there's no air resistance to slow things down. So, once something is up there and moving fast enough, it tends to stay up there, zipping around our planet like a cosmic race car on an endless track. It wasn't long before scientists started noticing this growing problem. By the 1970s, they were already warning about the Kessler syndrome, a scenario where the density of objects in low Earth orbit is high enough that collisions could cause a cascade, each collision generating space debris that increases the likelihood of further collisions. And so, from the advent of the space age, we've been gradually transforming the space around our planet into a celestial junkyard. What started as a race to explore the final frontier has left a lasting and potentially problematic legacy. Now our once clear skies are crowded with the remnants of our scientific achievements. Each piece of space junk, a testament to our inquisitive nature, our desire to push boundaries, and our ability to innovate. But as we'll see in the next scene, these remnants also pose a significant risk to future space missions and the long-term sustainability of our activities in space. What exactly is this space junk made of? You might be surprised. When we talk about space junk, we're referring to an array of objects, each with a unique story to tell about our journey into the cosmos. These objects include defunct satellites, spent rocket stages, and fragments resulting from disintegration, erosion, and collisions. Let's start with defunct satellites. These are satellites that have completed their mission or perhaps malfunctioned and are no longer operational. They range from small CubeSats, no larger than a loaf of bread, to massive communication satellites the size of a school bus. Each of these defunct satellites is a testament to our technological advancements. But they also serve as silent, floating reminders of our growing space debris problem. Next, we have spent rocket stages. These are sections of launch vehicles that have been jettisoned during a rocket's ascent into space. They've served their purpose, propelling our spacecraft beyond the Earth's atmosphere. But once they've exhausted their fuel, they become yet another piece of space junk, aimlessly orbiting our planet. And then there are the fragments. These are the remnants of disintegration, erosion, and collisions. They range from tiny flecks of paint that have chipped off spacecraft to larger chunks of metal resulting from explosions or collisions, even though these fragments might seem insignificant. At the high speeds they travel, even a small piece of debris can cause significant damage. Interestingly, the size variation of space junk is vast. Some are as small as a speck of dust, while others are as big as an entire defunct satellite. But regardless of size, each piece poses a potential threat. They're all traveling at incredibly high speeds, up to 28,000 kilometers per hour, making them capable of causing significant damage to anything in their path. This junk isn't just cluttering up our skies, it's also posing a significant threat. Each piece of debris, whether it's a spent rocket stage, a defunct satellite, or a tiny fleck of paint, is a potential hazard to our spacecraft and future missions. We've created an obstacle course in our own backyard, and it's about time we cleaned it up. Why should we concern ourselves with space junk? After all, it's out of sight, out of mind, right? Well, not exactly. This floating debris poses a significant risk to our modern way of life. Imagine for a moment the satellites that orbit our planet. These crucial pieces of technology facilitate everything from weather forecasting to GPS navigation, from telecommunications to scientific research. Now picture a piece of space junk hurtling at thousands of miles per hour, colliding with one of these satellites. The result? Catastrophic damage, potentially rendering the satellite useless and creating even more debris. This scenario isn't just a Hollywood blockbuster, it's a real threat. In fact, space junk has already caused problems. In 2009, an inactive Russian satellite, Cosmos 2551, collided with an operational American Iridium satellite. The event generated thousands of pieces of additional debris, cluttering our orbit even further. The International Space Station, a beacon of international cooperation and scientific progress, isn't immune to this threat either. Over the years, the station has had to perform numerous debris avoidance maneuvers to dodge this cosmic flotsam. What about future space missions? Well, as the density of space junk increases, so does the risk of collision. This could potentially create a cascade effect known as the Kessler syndrome. In this scenario, the collision of objects creates more debris, which increases the likelihood of further collisions. This could render space travel and satellite deployment an extremely hazardous and potentially impossible task. The impact of space junk isn't just confined to space. Occasionally, these pieces re-enter the Earth's atmosphere. While most burn up upon re-entry, larger pieces can survive and potentially cause damage on the ground. But the question remains, what can we do about this growing problem? As we look to the stars for our future, we must first address the mess we've made in our own backyard. The solutions aren't simple, but the first step is acknowledging the problem. So the next time you look up at the night sky, remember the invisible threat that lurks above and the imperative task we have at hand to clean it up. Addressing the space junk problem is a challenge that scientists and engineers around the world are actively working on. Our planet is surrounded by a cloud of defunct satellites, spent rocket stages, and fragments from collisions. This space debris poses a significant risk to our current and future space missions. But how do we go about cleaning up this cosmic clutter? There are currently two main strategies at play. The first is deorbiting defunct satellites. This involves using the satellite's remaining fuel to steer it back into Earth's atmosphere, where it will burn up upon re-entry. However, this method is not foolproof. If a satellite is out of fuel or malfunctioning, it cannot be deorbited in this way. This is where the second strategy comes in, developing technology to remove large pieces of debris. Organizations like the European Space Agency are working on projects like the Clear Space 1 mission. This mission plans to launch a spacecraft equipped with robotic arms to capture a piece of space debris and drag it back into the Earth's atmosphere, where both the debris and the spacecraft will burn up. These are just a few of the strategies being implemented and explored. Other ideas include using lasers to push space debris out of the way of functioning satellites, or employing large nets and harpoons to capture and pull in larger pieces of junk. While these strategies show promise, they are not without their challenges. For one, the sheer volume of space debris is staggering. There are estimated to be millions of pieces of space junk orbiting Earth, and each one poses a potential threat. Additionally, these solutions require significant resources, both in terms of funding and technological advancement. But the stakes are high. Without intervention, the density of space junk could reach a critical level, making space travel and satellite operation increasingly difficult. While we may not have a perfect solution yet, it's clear that the issue of space junk is one we need to tackle for the future of space exploration. So, next time you look up at the night sky, remember there's a lot more up there than meets the eye. We've journeyed through the origins of space junk, revealing how defunct satellites, spent rocket stages, and fragments from collisions all contribute to this growing problem. We've examined the composition of this orbital debris, a mix of various materials, each presenting unique challenges. We've also delved into the impacts of space junk, understanding the significant risks it poses to spacecraft and future space missions. Lastly, we've explored current strategies for managing space junk, a complex task requiring international cooperation, innovative technology, and responsible space practices. It's a vast, complicated issue, but one we must address to ensure the continued exploration and utilization of space. If you learned something new from the video, then please give a like to the video and share your opinions in the comment, and don't forget to subscribe for more such content and also share it with your friends and families.